Hello my dear students, this is Dr. Mohga and today we'll be explaining the lesson of density. Let's start with the lesson content. We need to know that density is mass per unit volume, know the equation with the symbols very well, know how to determine density of a liquid, a regularly shaped solid, and an irregularly shaped solid which sinks in a liquid with the proper calculations. We need to know if an object floats or sinks based on its density and whether one liquid will float on another liquid based on its density, knowing that those liquids will not mix. So, what is density? Density is mass per unit volume. Please be very careful with the symbols. Now, if my mass is in kilograms and my volume is in meter cube, then the density will be in kilograms per meter cube. If my mass is in grams and my volume is in centimeter cube, then my density will be grams per centimeter cube. Objects made from low density materials will have a low mass. If they have a high density material, they'll have a high mass. Just think of it of carrying a bag of feathers and a bag of rocks. The one that has low density, the bag of feathers, obviously has low mass. And the bag of rocks will be very heavy. They'll have high density, so that means they have high mass. Measuring volume. We have three kinds of things that we need to know how to measure the volume of. If I have a regularly shaped solid, all I need is a ruler. Then I'll apply the equation for that specific shape. So far, you need to know the shape of a sphere, a cube, and a cylinder. So please take a paper and a pen, write down the equations, know them very well, practice them on different kinds of examples. Sphere's equation is 4 over 3 pi r cubed. Cube is d cubed, and the cylinder is pi r squared times L. For an irregularly shaped solid, you need a measuring cylinder. We have 3 steps. Usually this question is for 3 marks. So the first step is I'll measure the water level in my measuring cylinder and I'm going to write it or note it down. Number 2, add the irregularly shaped solid and measure the new water level or mark it and write it down. Finally, I'll subtract the final volume minus the initial volume to get the volume of my irregularly shaped solid. Last thing to know about measuring volume is I can measure the volume of a liquid using a measuring cylinder, but I have to be very careful to measure, to do my reading at eye level to avoid parallax error. What is parallax error? If, for example, you're trying to read this number, if you are looking from here, knowing that light goes in straight line, if I'm trying to read from here, I will accidentally get the number that is a bit above. If I'm trying to read from the top, I will get the number that is slightly below. Hence, I should always read at eye level in order to make sure that my reading is correct and I'm avoiding parallax error. Here's an example. Please pause the video to write on your own and then unpause to check your answer. A paving slab has a mass of 73 kilograms and dimensions of 0.04 meter by 0.5 meters by 0.85 meters. Calculate the density in kilogram per meter cube of the material from which the paving slab is made. First step I need to do before writing any equation is make sure that my units are correct and matching. So density in kilogram per meter cube. I need to make sure that my mass is in kilogram and that my volume are all in meters to get meter cube. Checking, so 73 kilogram, correct. My dimensions are all in meter, correct. Now I can solve. I'll write the equation, substitute using density equals mass over volume to get the final answer. So density will be 73 divided by multiplying volume 0.04 times 0.5 times 0.85 will give me 0.017. So density is 73 over 0.017 equal 4294 kilogram per meter cube. Putting this in two significant figures will give me 4,300 kilograms per meter cube. Here's another example. Pause the video, please. Try it on your own and then unpause to check your answer. I have a metal block with 3 dimensions, the length, width, and height, and the density of the metal is 8.0 gram per centimeter cube, and they need me to find the mass. My original equation was density equals mass over volume, so I will rearrange this and I will have mass equals density times volume. Mass equals density times volume equal 8 times 2 times 2 times 3 to get the volume, which is 12. So my answer for mass will be 8 times 12 equals 96 grams. Next part is to know if an object will float or sink. In this example, they gave me 3 different blocks in water. So I will always compare my blocks to the liquid or the fluid I'm using my blocks in. Here, the fluid is water. The density of water is usually 1 gram per centimeter cube. So if the block I'm using has a density less than the density of water, which is 1 gram per centimeter cube, then that block will float. If the block has a density that is higher than the density of water, bigger than the density of water, then it will sink. As you can see, the iron block has 7.9 gram per centimeter cube of density, which is more than the density of water, so it will sink. The wooden block is a little bit less than the density of water, so it will slightly float. And the polystyrene block is much, much lighter than the density of water, so it floats all the way. Hence, whether an object floats or sinks depends on the relative densities of the object and the fluid it's submerged in. If the object is denser than the fluid, it will sink, and if it's less dense than the fluid, it will float. Here's an example. Please pause the video, try it on your own, and then unpause to check your answer. 2 objects P and Q are placed in a beaker containing a liquid. Object P floats in the liquid and object Q sinks. Which row for the densities of objects P, Q, and the liquid is possible? Looking at A, density of object P, which they already told me should float, and Q, which should sink. So float should be, the density of it should be less than the density of the liquid, and for sink, the density should be more than the density of the liquid. So for part A, 1.2 should be less than the density of the liquid, which is 0.8. This is incorrect. And the Q should be more than the density of the liquid, and it's not, so A is definitely wrong. B, density should be less than liquid, but it's more, so B is wrong. C, P should have a density less than that of liquid, it's correct. And Q has a density which should be more than that of the liquid, but it's not, so C is wrong. D, P has a density of 11.3, which is less than the density of the liquid, which is correct. Q has 19.3, which is more than the density of the liquid, which is correct, so the answer would be Q. Here's another example. Please pause the video, try it on your own, and unpause to check your answer. A cookery student pours some cooking oil into a glass bowl containing water as shown in figure 3.1. The density of the cooking oil is 0.92 gram per centimeter cube. The student accidentally drops a plastic spoon and a metal spoon into the bowl. The densities of the spoons and liquids are shown in table 3.1. On figure 3.1, label a suggested position for each spoon after each has fallen into the bowl. Use the letter P to label the position of the plastic spoon and the letter M to label the position of the metal spoon. As you can see, the water has a density of 1.0 and the cooking oil has a density of 0.92. Now the plastic spoon has 0.76, which is less than both. So the plastic spoon should be more above the cooking oil. So we will label P somewhere here. And the metal spoon, which should be labeled as M, has a density of 8.7, which is heavier than both. So M will probably be all the way here at the bottom of the glass bowl. Solution: P on top, liquid surface, M on bottom of bowl. Correct. Next and last part, we need to know the factors affecting floating and sinking. The factors affecting floating and sinking are upthrust and density. If the force of upthrust on an object is equal to the object's weight, then the object will float. Of course, you know the upthrust is the force that is pushing the object up. If this is equal to my weight, then the object will float. If it is less than the object's weight, then the object will sink. So if it's less, that means that the up force is much smaller, then the object will obviously sink. If the density of the object is greater than the density of the fluid, then it will sink, and less than the density of the fluid, then it will float, just like the part we took before in the solids. Here's an example. Please try it on your own, and then unpause the video when you're done to check your answer. 3 liquids P, Q, and R have different densities and do not mix. The liquids are placed in a measuring cylinder and allowed to settle. A small block is then dropped into the measuring cylinder and comes to rest as shown. Which statement about the density of the block is correct? It's equal. So I need to know the statement that's correct about the density of the block. So is it equal to the density of Q? Is it greater than the density of P? Greater than the density of R? Less than the density of Q? What do you think? Of course, the correct answer is C. Why? If it was equal to the density of Q, then it would probably be where? It's going to be with Q, somewhere here. If it is greater than the density of P, that means it's heavier, then it will be here. It's greater than the density of R, yes, because as you can see, it's way below R. That means it has a higher density than R. So it sinks beyond R. D, it's less than the density of Q, then it should be floating, it should be here. So that's why the correct answer is C. That's all for today's lesson. Thank you so much for watching. Please check the next video for the next lesson. Have a good day.